All right, let's take a look at this problem. Uh, it says consider the phasors shown below in this figure. And just quick note, so figure 523, figure 523, just make sure that they're the same figures, especially for your test. And they each have a frequency of 200 hertz. Let's pull that out real quick. 200 hertz. Write a time domain expression for each of the following voltages in this form. So, sinusoidal form. State the phase relationships between the pairs of these phasors. Okay. So, what we need to do is let's kind of piece together what we have here. So, in order to get this omega first, so omega is going to be equal to 2 pi f. So 2 pi times 200 was 400 pi hertz, or 400 pi radians per second. Okay. And then now what we can do is just go through here, and just write them out. So V of 1, so V1 has an angle, or has a magnitude of 10 volts. So we'll write 10 cosine 400 pi t. We're just following, this format, plus an angle of 30 degrees, and then we're done. We'll write volts at the end. Let's go on to number 2. V2 has a magnitude of 5. Write cosine 400 pi t. And remember, they all have the same frequency, so that's why we're writing 400 pi. And remember, for our angles, we want to keep them between 0 and 180, and we want to keep it between 0 and negative 180. That doesn't logically make sense right there. Hold up. Let's do it like this. Okay. So we want it one or the other. So in this instance right there, we wouldn't want to go like that, because that angle is going to be 210 degrees. And we don't want that. So what we want instead is this angle here, which will be 180 minus 30, which will be 150. So plus 150 degrees, and then the unit is volts. Okay. Then V3 is just going to be equal to 10 volts for the magnitude. Cosine 400 pi t, plus it's at a right angle here, so that's 90 degrees, and that's also volts. So that is the first part. The next part is to write the relationship between those all. So writing the relationship, I'll write, let's look at V1 and then V2. So we'll say V1 lags V2 by, let's see, so V2 is at 150 degrees, V1 is at 30, so it lags it by 120 degrees. Okay, so you can see that from here, that V1 is 120 degrees behind V2. That's all that means. Okay. Another way of saying that is V2 leads V1 by 120 degrees, and that's just the same expression. Okay. So now let's go and take a look at another set. We'll look at V1 and V3. Okay. So I can say V1 lags V3 by, so V3 is at 90 degrees, V1 is at 30 degrees, so it lags it by 60 degrees. And then we can just say V of 3 leads V1 by 60 degrees. Okay. And then finally, let's look at V2 and V3. So we can say V of 2 leads V of 3 by, so V of 2 is at 150, V of 3 is at 90, so that'll be 60 degrees. So leads V of 3 by 60 degrees. So right here, 60 degrees. And then right there is also 60 degrees. Okay. And then, of course, the other way of saying that is V of 3 lags V2 by 60 degrees. So it's just whatever's leading and whatever's following is all it is. And whichever one's ahead of the other is considered to be the leading one. All right. So just a quick general concept with that. We're going to see where that comes into application in just a bit.